Hello world, this is Joseph with LV, EAV and more, my entertainment channel, and welcome to my holodeck. My first video, the set wasn't quite ready, but now I finished it and kind of went with the Star Trek theme because I'm a really big Star Trek fan. In fact, I'm part of the USS Windrunner right here. I'll show you in the slide in a second. But this being my entertainment channel, I wanted to basically replicate what I see on TV, or what I saw on TV when I was a kid, which was Star Trek The Next Generation. Different uniform, of course, but I think you all recognize the holodeck. It was so much fun because really it was all about entertainment there in the holodeck. You could do whatever you wanted, and that's kind of my channel. I just do what I want, show you guys some interesting things. Right now I want to start on basically one of the first not really products, but ideas of mine about how to build a really good party speaker. And what do I mean by party speaker? Well, kind of everybody knows about the JBL Party Box if you're into basically Bluetooth speakers and you want a high-end Bluetooth speaker that sounds good. That's kind of going to be our goal, but we're going to find out it's actually not too hard a goal to achieve that JBL sound. There's a lot of reasons why, and we're going to go very into depth into this. So first, as this part of the first in a series of videos, we're going to go on study some theories and stuff about what makes a sound system really good and how to build it yourself. Because I am an electronics repair person, I really say you can build this stuff yourself and really match or outperform what is currently available to the consumer. So let's get to the slides. Okay, here we are at the slides. A little more about me actually. Quite a while back I was actually in the Navy as a nuclear electronics tech, so I have a lot of experience with working to the component level on circuit boards. I also have a degree in manufacturing engineering from Cal State Long Beach. So I have a lot of experience in both aerospace, avionics, electronics manufacturing, regulatory compliance. But again, this is kind of my entertainment channel. And the things I like to do for fun, I like Star Trek, like a lot. I mean, obviously with my set, my costume, and this little official ranking me as ensign by Commodore Rochelle Meisner. If you guys are interested in Star Trek The Fleet, please check it out. It's a real fun cosplay fan club. We have 2 ships here in Las Vegas, and it's a lot of fun. Well, let's get on to the actual party speaker stuff. But first, why do I repair electronics? Well, obviously, saves money. And not just repair, build your own. I mean, like, this whole channel is all about not showing you exactly how to do stuff, but more bigger picture kind of a presentation. I'll show you what you can build and how to build it. Not step-by-step stuff. I mean, it really only requires basic soldering skills, and I'm not here to teach you to solder. In fact, YouTube's a great resource to learn how to solder. There's a lot of excellent resources, and all I really require you to do is know how to use a multimeter to identify positive, negative volts, and how to solder connectors together, connectors and wires. Nothing really advanced. But more importantly than just saving money, we're saving the environment, people. E-waste is really, really toxic. And this is just kind of a bad thing for the environment. Electronics have lots of nasty chemicals associated with its manufacturing and with its disposal. So yeah, e-waste toxic, manufacturing is toxic. So you really want to make your electronics last as long as they can. Fix them whenever possible, upcycle them when they really start going on you, because nothing lasts forever, obviously. But there's kind of an inherent flaw here. Manufacturers not only design for planned obsolescence, which is a thing, but are increasingly clamping down on DIY and professional repair, i.e. they're making their technology disposable. That's not good, people. I mean, I've been repairing like professional grade amplifiers to the component for over 20 years. And now that's just not a thing anymore. When the amplifier is out of warranty, it really can't be repaired unless it's a simple repair like a power supply thing, in which case they really should have just made the power supply replaceable in the first place. But they don't, because they're designing for planned obsolescence. And we should have a right to repair. That is vital, people. This is going on like all over the world, and especially in Europe. They're making manufacturers make things repairable. This is kind of like going on in the background too. Like there's a whole fight with Apple trying to resist USB-C. So now we have lightning chargers for Apples in the US, and they're forced to go USB-C in Europe. And in my opinion, I like USB-C because all the other cool 5-volt little gadgets run on USB-C right now, including like Android phones. So it's like good to have these kinds of standards. So I design my electronics a certain way. You're going to see a very common thing. Let me show you like basically what I mean. This little connector here. It's red. I don't know what color it looks like on this webcam that I'm using, but those are known as T-plugs. The original name brand was Dean's, and arguably it is a better product to get the name brand one. But like I said, we're trying to save money here, and these connectors cost me something around 25 cents or something, so I just use them everywhere. They're a really good connector, and we'll go over that further into our presentation. So, with product life cycles being pushed faster by manufacturers with purely profit motive in mind, repairs really cut into the profit margin. In fact, this is why they're getting rid of us professional repair people. They're making us kind of obsolete by making their stuff unrepairable. Kind of a really good historical example that I'm going to mention, and I'm sure a lot of people on YouTube with some electronics experience know about. Heathkit Electronics, specifically the Heathkit amplifiers, Heathkit test equipment. It was an amazing product. Back right around post-World War II, what happened was there was a lot of government surplus electronics like from the war, and this Heath guy actually bought a whole bunch of surplus stuff, and instead of trying to manufacture it into a product himself, sold them with very good plans to actually build the thing you wanted, which back then, amplifiers were very expensive back then. They've gotten a lot cheaper now, but back then you really were better off building a Heathkit amplifier than getting basically any other name brand amplifier that was out there. This was post-World War II. The electronics weren't that advanced, and you could actually build it yourself. So yeah, you could build amplifiers that were on par with the leading manufacturers. You really did have to learn how to solder. I'm trying to remove even that hurdle into building your electronics. And of course, with the knowledge gained by building the product yourself, in a good modular design system, which we'll get into later, the amplifiers could be repaired endlessly. And that's my kind of philosophy. I want you to be able to repair your technology endlessly with modular construction. So if any module fails, you can replace it with any other type of module. That kind of interchangeability of components, basically I don't see, because manufacturers want to tie you into their little environment, so you keep buying their name brand, and it's going to break because that's how they make them, and since no one can repair them, you're going to buy a new one. So there's also another world to this. Like I said, I was a manufacturing and regulatory compliance engineer, and due to increasing electrical product regulations, manufacturers have also adopted modular design concepts. They're actually doing kind of what I've been doing in the background, but not telling you. This streamlines product development because they're pushing these like planned obsolescence cycles faster and faster by making the product cheaper and cheaper. It's true, guys. It's true. Manufacturing engineer here talking. So you combine that with planned obsolescence, the only way to keep a continuous income stream is to suppress the right to repair. And they're doing a great job of that too. I used to repair the stuff and now I can't. So how can they convince you that basically their modular design is better than my modular designs? Well, the only corporate strategy then is to lie about your product's performance. And this is kind of also going on in YouTube. I see all these people like demoing these party boxes, and when they actually measure the performance, it is not making the numbers that JBL claims. They're hitting only like maybe 90 dB when it should be hitting 100, 110 according to the numbers. So somewhere in there is some sort of lie, because you can't actually measure it, and nobody these days are really technical enough to tear down these things, especially these cheap things. You do see some of the really high-end stuff being torn down and measured and doing all this by all of these higher-end like hobbyists, but you don't really see a lot of people tearing down to the little individual components and examining them. The consumer grade stuff, the cheap stuff, the stuff you want to buy just because you want to have it, instead of investing thousands of dollars for essentially a few hundred in parts. So with all those lies of promising to be better, faster, more powerful, more feature-laden, Bluetooth included, and all this stuff, when in reality it is really easy to beat the performance of even JBL's products nowadays, especially their consumer line. I'm not going to say I like the speaker designs we're building is going to beat anything in their SRX line, but it will be real close, I promise you. But you're talking about their IRX and their PRX line? Oh yeah, we're going to be there. It's going to be better. Like, I promise you that. Like, I'm the person who used to fix this stuff for you and now can't, and now telling you, you really should be building it yourself, because this way there's no planned obsolescence cycle here. You guys fix it yourself. You guys upgrade it yourself. The technology is going to improve, and yet you're still going to be able to continuously improve your system with the continuously improving technology. That's great. That's kind of like my dream. And literally, I'm having to build my dream because no manufacturers want to realize this holistic approach to building their electronics. So another like fact back then, why the manufacturers seem to be so prevalent in lying. Back when a lot of people still built their amplifiers, it was not hard to find a person nearby. Your average TV electronics repair shop had the person with the skills and knowledge to tell you, hey, these guys are not like making their amplifiers actually put out the wattage they're saying. And so that would spread around quite readily. And basically, if you lied as a manufacturer back then when there was a lot of technicians to tell you otherwise, boy, you couldn't get away with it. So companies like JBL had to put out how they measure their things, or how they measure their power or their performance, and other technicians could replicate it, and that was the mark of JBL's quality. It did what they said. They weren't lying back then. When they said it was a 100-watt amplifier, it was a 100-watt amplifier. And you know, modern technology has changed this. YouTube has changed this. There is a couple of like YouTubers that I really like because they are exposing manufacturers' lies. One of them that I'm going to link in the description is Williston Audio Labs. I like that guy. He actually puts out like information about how car amplifiers perform. Now, we can use car amplifiers, we can use like home mini amps. We're going to get into that a little bit later, but YouTube is changing this, and hopefully we can get this right to repair movement moving along better in the US, because it'll be better for everyone when you're not just constantly tossing electronics that keep breaking. So YouTube allows people like me to truly show, like in the Heathkit days, that electronics doesn't have to be difficult. I'm going to make the soldering work really simple, and if that even like kind of overwhelms you, I'm going to show you that I'll build and sell you guys adapters custom made for your use to build these systems yourself, just like mine. But I'm going to tell you that the way I design mine, I prefer it versus trying to use adapters. I'd rather have higher current connectors directly to the amplifiers. And again, we're going to get to that later. So in the Heathkit days, electronics didn't have to be that difficult, but you did kind of had to have more soldering experience. And I know people back then worked with their hands a lot more because you can always order the plans for a DIY hovercraft kit from Popular Mechanics back then. And I knew a lot of old guys now that were young guys or young kids back then that built their own hovercraft in their dad's garage from a Popular Mechanics, like a little plan that they bought. Lots of fun talking to some of these old timers about like just how much craziness they got into, like building stuff with their hands. Truly a lot of fun. Work with your hands, guys. It's nice. It's fun. But electronics doesn't have to be difficult to build or repair, especially when it's designed for easy building and repair, and that's where I'm focusing right now. Easy build and repair. This is a deliberate choice because when electronics used to be repairable and they now aren't, it's purely profit-driven motive instead of quality-driven. And part of quality is quality products should both last a lifetime and be repairable. You have that combination, basically, honestly, you'll cut me out entirely, and that's what I want. I don't want to be constantly repairing like designs that I put out that were bad. So I'm going to make it so that my products go out there and never come back, because in the worst case scenario, you can repair it yourself. Don't have to involve me. Or with a little bit of like practice with soldering, don't involve me at all. Build it yourself. I'll show you how. One of my design principles also involves upcycling of electronics, specifically of power supplies. Some of the best products that I've seen, just like in terms of power supplies, is server power supplies. You're not going to find more powerful 12-volt DC power than a used server power supply, and it's not going to be you're not going to find a better quality power supply. Back when I started doing these experiments with car amps and powering them with used server power supplies, I was getting a 600-watt server-grade power supply for $15. That's insane, people. These things are like 600 watts of output for like $15, and they're super clean. They're generator friendly. They have power factor correction built in. They're upwards of 90% efficient. They have built-in like fan cooling that gets faster as you draw more power. So these things are super safe, super rugged, built to run servers 24/7. So these are the most rugged like power supplies you can honestly buy. And no, JBL is not putting server grade power in any of their products. So like, that's not a question. You use server power supplies, that's going to be the last power supply you buy, unless you like physically abuse it or dunk it in water or something really ridiculous. But I've never had one fail yet, and I use these for everything. So amplifiers are kind of going to be our perfect example of like technology, because they've been evolving over the years just like computer technology, but they've had a head start. Amplifiers have been around since like basically electricity's been invented. Or basically since the vacuum tube has been invented, amplification has been a thing, and we've been getting more power and more efficiency by basically advancing technology from vacuum tubes to transistors, now to switching amplifiers, Class D amplifiers. This is kind of about as good as the math allows you to get. Some Class D amplifiers are approaching 95% efficiency, and that's basically perfect. There's not going to be much more gains in terms of technology. Like, we've kind of reached this kind of funny little point where Moore's law, like if you study computers, is kind of like faltering on us, because the microcircuitry has gotten so good we're reaching the actual limits of physics. That's really interesting, because this is like literally almost Star Trek level technology in terms of efficiency. Like even in like Star Trek, some of their technologies weren't approaching 90% efficiency, because 90% efficiency seemed like sci-fi back in Star Trek TNG days. So we're actually like we've already surpassed the original series. I mean, like that technology, like the computers, it was not realistic. But now we're actually approaching even the next generation level technology with 90% efficient amplifiers. That's crazy. That's sci-fi. But with that, with Class D amplifiers, amplification has completely bottomed out in price. I'll tell you a little story. Back when I was starting way back in the late 90s in car audio, it was pretty typical to pay about like $5 a watt of power. So if you wanted a good 100-watt amplifier, you were paying $500 for it. That was your like Rockford Fosgate. That like with inflation basically is pretty expensive nowadays. But now you can easily get a 100-watt amplifier. Instead of for $500, you're talking a 100 amplifier for $30. Yes, it really is. And the funny thing is, these little Chinese-built amplifiers are lying less than JBL. So take that with a little grain of salt. JBL's lying so much that a 100-watt amplifier is equaling their performance, and you're getting it for $30. There's no $30 amplifier you're getting from JBL. Period. No. So, like the Class D amp chips in a name brand amplifier is no better than any generic mini amp, like those Chinese mini amps I was just joking about with earlier. More on this topic again on amplifiers when I introduce my Rockville Party Tower concept. It's going to be really fun and interesting, guys. We're going to fully test this this speaker concept system out. But do you really think the JBL Party Box 1000 is 1000 watts? It isn't, and I'm going to have multiple ways to prove that. It's not 1000 watts. It's in reality about 120 watts. And it's actually kind of easy to prove that. JBL was once synonymous with truly accurate tests and measurements. Remember, guys, like back in the Heathkit days, early JBL days, when JBL said their speakers handled 100 watts, they're going to handle 100 watts 24/7 because it was pink noise tested, and their amplifiers truly were cleanly 100 watts, but these were behemoth rack amps. A 100-watt amp that was like a couple hundred pounds, really, and that's like post-World War II. This is like kind of like the advancement of technology that a 100-watt amp now fits in the palm of your hand. Here, let me show you. This is a 100-watt amp right here. You see, it's fitting on this sheet of paper. It's not that much bigger than my hand, and that's not the actual amp. And that's not the actual amp. The actual amp is a microchip. This is a TPA3116D2. It's my personal favorite amp chip because it has the widest voltage range. And this amplifier will even run on USB power, and we'll prove that out when I'm showing you the designs that I create. But here's the actual amplifier here. I've taken this apart because it broke, and I wanted to see like how easy it is to replace the chip. It's actually kind of hard. This is very small. Let's see. Oops. Let's get our focus down. Let me get the focus back. All right. This, you got to get up close. This is a microchip, so here's my pinky, guys. See, this is a TPA 3116D2. It's about the size of my pinky fingernail. That's a 100-watt amplifier, people. That right there. Not a big transistor, not a big hunkin' chunk of vacuum tube. 100-watt amplifier microchip. So they make them into even smaller amps, but when they get really small, like they kind of overheat. So this is kind of like the ideal size for them. It's small. I can carry it in my pocket. It's a portable amplifier that I can use to power any kind of speaker. That's just really fun because I actually like to go to the thrift stores, and I bring this amplifier and a little USB power bank with me, and I can test the speakers. Yeah, it really can work on 5-volt power, and the op amps are really only rated for 22 volts. They're NE5532. Oh, yeah, they're NE5532s, I believe. But those chips are only good for about 22 volts, but a good quality design like this, I ran it on 24 24 volt power, like for basically years. I have old op amps, old amplifiers that use these op amps, and they ran fine on 24 volts basically for years. So that's a 100 watt amplifier there, and the JBL Party Box 1000 honestly has about 120 watts. So now the reason why they can claim 1000 watts, it's nearly impossible to find technical documentation on something like the Party Box. They just keep claiming it's like a 100 watt or 1000 watt amplifier and like 1000 watts RMS or 750 RMS, or you see all sorts of stuff, but you don't see what tests they used. Like, you don't see really much of anything, so you have to do a deep dive. So really, before you had to buy the product, but the papers it came with showed the technical performance numbers, and now the specifications don't list what standards they're using, what, like, are they doing it at partial power, full power. You can't even see a fuse rating on the actual appliance. So these are not directly lies, but they're lies of omission. And lies of omission are lies nonetheless. And at this point in my life, the lies stop here.
No! The line must be drawn here. This far, no farther.
Let's face it, manufacturers lie about the wattage. I'm making this point several times because it really is a really big problem with me when manufacturers lie. As a quality engineer, I didn't want to lie, and yet it's like, what else are you going to do when everybody else is lying and basically you're forced to? That's not a good place that any engineer wants to be in, so it's like, that's why I'd rather start my own electronics repair company, so I don't have to lie. I'm telling you guys the truth, best that I can figure it out. But then again, I've been repairing these amplifiers for years. I got the degree in engineering. I didn't want to lie when I was an engineer, so now I find myself starting my own electronics repair business where I don't have to lie to my customers. You know, it used to not be that way. Used to be when JBL rated something, they rated it right. Worse yet, this is what really kind of bugs me even more. The lower end JBLs lie more about watts than the higher end. You can actually calculate the correct wattage on the JBL SRX line of pro audio speakers, which in my opinion is the only line you should be starting out with JBL if you actually want the actual JBL quality. The IRX and the PRX lines, they're a joke. I'm not kidding, they're a joke, and we'll prove that again later on in the video. So again, here's some more proof, just an easy way to look at it. The Party Box 1000 is not 1000 watts. That's not what you think it is. That is actually the figure 8 plug. And let me get one here for you. Okay, so that's the figure 8 plug. You've seen these. It's basically a low power plug. In fact, in Europe, the most you can have on this is 2.5 amps going to it. Simply because it makes it easier for manufacturers to produce the same product in the US as Europe. They're also current limited to 2.5 amps of fuse inside it. They don't actually use fuse, they use what are called PTCs, but it's basically a resettable fuse. That's not that important until they start burning out on you because you're running bad power through them, like these speakers, the amplified speakers, really don't like to be run on modified sine wave. It tends to burn out the bridge rectifiers in them. It's because they use cheaper power supplies that don't have power factor correction, like the server grade powers or even the computer power supplies, like for laptop chargers. They have active PFC according to European specification. Any power brick over 75 watts of power has to have active PFC, and that really helps smooth out the current spikes that tend to burn out the power supplies in these low voltage electronics. So all of these are technically what's called low voltage electronics, and there's a few different rules and regulations that specifies what low voltage means. I take it to basically mean, for myself, because there's a lot of general specifications here, we stick with that 2.5 amp fuse rating, which means we can never be consuming more than 300 watts when we run 2.5 amps. So anything connected to this plug cannot be consuming more than 300 watts. That's really important, because you don't want to burn out your home's electrical system by running too much power, and maybe even setting it on fire. So not just the current is limited, but the power is limited to 300. You also have to consider inefficiencies of your amplifiers. The typical switching power supply is only about 80% efficient. You might push that up to 90% with really modern supplies, but that's not what they're putting in basically JBL's consumer stuff. They're going to be putting in a regular, basically, switch mode power supply, 80% efficient, poor power factor. So it leads to high volt amp ratings, and that basically sucks up any current overhead in any portable power generation system, like an inverter generator, or a full sine wave inverter, or a modified sine wave inverter, which again will tend to blow up JBL's consumer grade power supplies. So we have to limit ourselves to less than 300 watts consumption. With an 80% efficiency rating on the amplifier, there's no way, you're going to get 240 watts of output. So there's multiple, basically power wastes here. 300 watts of consumption is at the power plug. You're going to get about 240 watts at the power brick. And out of the amplifier, out of that 240 watts of DC consumption, you're going to get about 192 watts. So with a 300 watt rated consumption device, at most, with consumer grade tech, including the kind I'm showing you, you're only going to get about 192 watts RMS out of it. You're never going to surpass that unless you're putting some really, really expensive, efficient technology, in which case, no, they're not putting that. I promise you, I fixed them. It's not that way. They put bottom of the barrel components in their power supplies and average Class D amplifiers, and then start lying about the wattage. So this is why you don't see RMS wattage on the back, or you don't even see RMS wattage correctly labeled in the technical documentation. The only way now we're able to tease out what kind of power we're getting, we have to look at the back of the actual unit. And I'll show you in this picture right here of a JBL PRX 800 series amplifier. They're claiming 1500 watts, but look at the picture. Look at this picture, guys. Yeah, do you notice the 300 watts consumption? That's because there's IEC regulations that basically limit the amount of not just power, but the volt amps that the speaker can consume. It cannot consume more than 300 watts, and that's including any volt amp spikes. So there's a lot of power factor going on here, and this has nothing to do with the amplification. The consumption has nothing to do with the amplification other than it's the maximum power that the thing will consume, not what it produces. So it gets confusing there. So that 300 watt rating is the most it'll consume. With the inefficiencies of the power conversion and the inefficiencies of the amplifier, you're only getting 192 out of the original 300 watts. So look at that. I mean, the safety factor there is that Europe, basically for green energy reasons, limits the amount of power in consumer goods. And notice on this one, here we go. This is the typical 24 volt 10 amp power supply that you're going to use on a TPA 3116 or even any of the newer TPA 3255 Class D amplifiers, which I said amplifiers are interchangeable nowadays. Class D amps are Class D amps. There's not much difference. All that matters is how much power you can supply them with, and for safety and for safety, low voltage safety reasons and power consumption reasons and volt amp limitations, power factor reasons, essentially all your bricks are going to be limited to 240 volts. 24 volts times 10 amps gives you 240 watts. If you notice, 2.5 amps right here. That's 2.5 amps of consumption. The same 300 watts, because 2.5 times 120 volts that we got here in the US equals 300 watts consumption. So the JBL PRX, this is what people like sort of, I guess, consider pro-grade technology. I don't consider it pro-grade. It's not heavy duty. They don't have the right power supplies. You can't run them on a generator. The power supplies are just kind of average. It's no better than what's in here. In fact, I'm going to show you that a used laptop power supply is better. So, again, let's factor in the power supply inefficiencies. I just told you about the 2.5 amp rating for the JBL PRX. Like the PRX 815, PRX 715, again, just the newer model because, you know, accelerating that that product life cycle so they can keep selling you more models and they don't have to warranty repair their old broken ones because they're kind of designed for planned obsolescence. So it gets funnier and funnier, guys, or at least funny to me because, you know, all those lies. So the PRX has 300 watts of consumption. Yeah, that's not that much when basically this is your 300 watt consumption power supply. Same thing. So there's no way that the JBL PRX1 is getting more than about a couple hundred watts to its speakers. And if you look at the drivers, they're actually kind of lower end drivers. They're not like JBL's like best differential drive woofers. And it gets even worse when you go into the party box because it's really consumer grade, like just average everything. Not so great. If you look at pictures of the JBL party box, it's got this plug. And in its own literature, JBL admits that it has 150 watts of consumption. Oh, excuse me. So, if it has 150 watts of consumption, like, let's do our calculations here, people. We've got 150 watts of consumption. So out of that 150 watts, you're going to have 80%, which leads you to 120 watts for the power supply. So the power supply is supplying no more than 120 watts to the amplifier, and the amplifier is going to be your typical Class D amplifier at 80% efficiency, and I'll show you with my measurement techniques, like right down here, how you can verify the efficiency of Class D amplifiers or any amplifier that's of a low enough wattage for the test rig you built. I built mine to handle up to 400 watts, so I generally don't measure anything over 400 watts, but again, for low voltage safety reasons, I keep my amplifiers to around 400 watts or less consumption. You're still beating this 300 watts. My designs will reach 400 watts RMS at the amplifier, so you're consuming quite a bit more than 400 watts because nothing's perfectly efficient. But with our 120 watts of power supply to our amplifier, we multiplied that by an 80% efficient amplifier, and we get 96 watts. The JBL Party Box is not 1000 watts. It's more like 100 watts RMS. And that is a very, very easy to beat number. Because I've actually tested this with the power rig that I'm going to show you. I've tested this amplifier at 92 watts. So we're within spitting distance of the JBL Party Box 1000. Easy to beat, people. It's no more than about 100 watts. And this kind of proves it. This kind of figure 8 plug kind of proves it's a very low power, low voltage device. And we can easily test this power. I have my own speaker test design rig, and here's a little diagram of it. You got a voltmeter here. It requires two multimeters, but this is standard for engineering how you measure like power in circuits. You got a voltmeter connected in parallel to the load. You got an ammeter connected in series. This way, any like thermal changes here will be captured by the ammeter. If the resistance increases because the temperature increases, normal, it's a positive temperature coefficient for resistors, especially wire wounds like I use. So this goes up in resistance, you're going to catch a lowering of amperage and a raising of voltage if you have like different power supplies that aren't quite so stable. The two multimeters will tease out the actual truth. If there's a voltage difference here or a resistance difference here due to temperature, and like it's gonna catch it. And normally you would have to use an oscilloscope, an O-scope, to be able to see the distortion. But in my experience, nobody knows what that distortion sounds like, because ultimately we're going to stop our amplification when we're going to be hearing distortion. That's just common knowledge among audio techs. When they hear the distortion, they know they've reached maximum volume. And the way we're going to do that, we're actually going to connect the speaker across the load. But if we did that, we'd be diverting half the power into the speaker, and that would be really loud, because if my amplifier is 400 watts and I'm basically diverting 200 watts to my speaker, I'm going to go deaf. Like, I don't want to do that. So instead, to be able to hear the distortion, we have to run a speaker like a lot quieter. So I put a 220 ohm resistor in line with the speaker. That drops the load, because this load's going to be anywhere between 2 and 8 ohms. That's the way I built my rig, and it's going to drop about less than half a watt at maximum capability, and that's just enough for you to hear the distortion that you would normally see on an O-scope. And now we have multiple ways to verify this without having to buy really expensive equipment. You can buy two cheap multimeters and a couple high wattage resistors and a little resistor here, and use a used speaker. That's what I do, and it actually reads the power very accurately. So let me show you my test rig here. This isn't nearly as complicated as it seems. What I have here are my two multimeters for power, my amplifier right here. I've got my phone feeding it a 60 Hertz signal. That just happens to be a little more friendly to a non-RMS multimeter. This Fluke 77, it's an RMS multimeter, and it's good up to 20 kilohertz. So basically this gives me a really accurate current reading. And at 60 Hertz, it's kind of hard to see on the phone because of the lighting reflection. At 60 Hertz, this has no problem reading AC voltage. So a lot of times they'll, like the guys who test amplifiers will test at 1 kilohertz also, and they'll actually get more power at 1 kilohertz. So this is a more brutal test. So here's my resistor bank. Right now I have it wired to 2 ohms, so I'm only using these two 4 ohms in parallel. These two aren't connected, and I don't have my fan on because we're only going to be testing a short burst to see what this amplifier can do. This is the Knob Sound NS03G sub. What's really nice about it is I can actually turn it to full range with the switch I installed. If you open this up, there's actually a tiny jumper inside that switches it from full range and subwoofer. It's originally a subwoofer amp, but it's a full range amp. And once I put the switch, it's either subwoofer, full range. I also put this little USB output on it because it's part of my design for the party speaker concept. But right now, this is a bone stock amplifier. And I've just done a few modifications, like this power lead with this cord. This is a higher current T-plug, or Dean's connector, and a thick 16 gauge connector. This will draw about 5 amps at 24 volts. This is a 24 volt 10 amp power supply, so we're not power limited here. So what we're going to be able to see right now, this is set to AC voltage, or AC current, I mean. This is AC current, and this is AC voltage. So our power equation basically is really easy. Power equals volts times amps. So we just take these two figures, multiply them together, and we get our wattage output. this is a non-inductive resistor bank, so even if it had inductance, these meters would capture it because you're capturing both voltage and current. This is how you do it, like when you're doing engineering. So this is actually a valid test as long as you're using a valid meter, and this fluke is close enough, and this is accurate at 60 Hertz. So let's start our test. We're feeding 60 Hertz from our phone to the amplifier, and I turn it on, and you're going to hear 60 Hertz. It's volume knob on this is a little scratchy, but there you go. You're hearing 60 Hertz. There's a jet plane in the background right now, so let's turn it down. Don't want to overheat my resistors here. They're not doing too bad. But here, let's wait for this plane to pass and let these resistors cool off. This resistor bank, by the way, is mounted on an old amplifier chassis that I actually extracted from that board I showed you earlier. This kind of broke on me. It was actually the Bluetooth module that broke, so I don't like that. And that's why I don't like integrated Bluetooth on these amplifiers, but that's now the only way you can buy them. So sadly, when I go over my amplifiers, I'll show you what kind of amplifiers are available. Okay, that jet plane has finally passed. Let's try our test again. Excuse me here. Okay, so listen for that 60 Hertz tone. We kind of all know what it is if you've heard 60 Hertz hum go through your audio system. Don't know if you can hear that. But right now, oh, do you hear that distortion? If I turn it up, that distortion gets really evident. And that's the amplifier distorting, not the speaker distorting, because you can see it's barely moving the speaker. But you hear that distortion. So I'm gonna put it so where I can hear the distortion, and this is where I call the clean power, basically. Right there. Do you hear the harmonics going into the tweeter? That's basically the waveform flattening out because it's clipping. So there's some distortion, but it still sounds pretty much like a 60 Hertz waveform. These amplifiers do reach distortion earlier than a Class AB, but they have a kind of cleaner sound to their distortion. Some people describe it as a tube sound when these are driven hard, and they really do have that, and I'll show you that tube sounding like sound that these amps are capable of. But take a look, we're running 6.22 times 12.43, 6.22 amps times 12 point, oh, it says 46. Right now, we're getting 77.5 watts. And that's clean watts. If you're using this for a subwoofer, you can actually push that distortion a little because the subwoofer's not going to care, and you're not going to be able to hear that kind of distortion over the distortion of the subwoofer itself. I'm going to make sure my resistors aren't getting too hot. They're kind of hot right now. So I got to turn on the fan to help cool these off. And in fact, when I'm running some of my longer tests and I'm testing, I have this little sprayer full of vodka here. So I turned on the fan with a battery. It's a battery operated fan. And I just spray it with vodka, and that helps cool it off because these things will get pretty hot. Like right now, with that vodka spray, it's already drying off. We're at 115 or 105 degrees here. So let's try again. And I'll push it into more distortion, and you'll see you'll get a little more wattage. So we're still at a 24 volt input here. So you can see it climbs up pretty high. But you can push it up pretty high and get a pretty decent wattage number, but those aren't very clean watts. You might only need that in a bandpass sub. But this is about 10% distortion right here, so that's where we'd call it. So let's calculate our power. I've been listening to these speakers long enough to know where I hear what kind of distortion is what. So 7.43 times 14.54. 14.54 equals 108 watts. So I'm pushing it to its 10% distortion limit, and because I have good high current conductors, I'm actually getting a little more than its rated power. Now the amplifier is going to tend to overheat if you run these sine waves that long, and you really shouldn't be just constantly running sine waves because that's not music. But at that 10% 108 watt kind of peak, if you just hit that 108 watt peak, you're not going to hear that much distortion. So this is a real deal 100 watt amplifier. Super clean watts, like things that you can actually use for like full range speaker, it's 77. But it's somewhere between, honestly, 70 and 100 watts, which is right in the same range as the JBL Party Box 1000. So that right there kind of proves this is an amplifier on par with what you see in a JBL Party Box 1000. And this is the Knob Sound NS03G. Let me get the autofocus here so you guys can see this. There we go. Okay, so this is the Knob Sound NS03G sub. Like I said, you can actually run this full range. But you see that? The sub and FR. I have the little jumper to full range. So this subwoofer amplifier is now a full range amplifier. And it actually has pretty good components inside. And when I go through the amps later, you're going to see, like, specifically that this is kind of a hard to find inductor. And it's very good. It's an edge-wound voice coil using rectangular profile wire, so it's super low resistance, and that's what gives these TPA3116D2s kind of an edge. If you put in a really good inductor, you really do get the 100 watts output, and that's the big difference. This modern knob sounds put in the good inductors, so you actually get the wattage. JBL actually uses toroids. Like, toroids are good enough. They're these. They use basically these, but these have more resistance. These are toroidal inductors. Let me show you. This is actually a custom-made power supply that I built for some experiments. But these are toroids. They're like little donuts with copper wire, and you can see there's a lot of copper wire in there. And basically that's what you'll find in the JBL Party Boxes, JBL PRXs. I don't know if it's in their SRX line, because those are the crown amplifiers, and I simply don't repair those. We just had to just replace the whole amplifier because, again, none of it was made to be repaired. But these, I mean, this is a $30 amplifier, and you just saw that it put out 77 clean watts and about 100 watts if you push the distortion up, and that's okay if you put it in a subwoofer. So if you design this for a subwoofer, you can really push 100 watts out of here, and that sub will really do it. But we'll show you later in the amplifiers that basically going from 70 to 100 watts doesn't get you that much. It gets you about a dB. I'll show you the calculations, because there's actual calculations for this stuff, converting decibels to voltage to wattage. It's kind of basic engineering. But this is my power test rig, and I've tested all my amplifiers throughout the years like this, all the way from car amplifiers to like these Class Ds. And if they are rated properly, I can rate them properly, and I actually get numbers pretty close. Like if I put in a little more sensitive speaker so I can hear the distortion, I know I personally can reliably hear 2% distortion, whereas just common knowledge is you're not actually going to hear below 5% distortion in music. So these distortion figures, you're going to hear audiophiles going like, it's got to be less than 1%, like THD. It's not really needs to be that way, because your speakers are going to be the greatest source of distortion, and people don't measure the distortion of speakers, because if they actually did, they'd find out, wow, their speakers are the weakest link in the chain of distortion. So if your speakers are distorting 10, 15% even on higher wattage, an extra 5% from the amplifier is not going to be doing that much. So you gotta kind of take your speaker and amplifier design as a holistic, like a combination of factors. But ultimately, 1 or 2, even 5% THD is not going to matter on a subwoofer, so you can truly call this a 100 watt car subwoofer, or a 100 watt subwoofer amplifier, and a 75 watt, like a regular full range amplifier. It was never even meant to run full range, and yet it's 75 clean watts, full range at 2 ohms with 24 volt input. So, this is a fantastic bargain, guys. Knobsound NS03G sub. I'm not even advertising for them. I bought these for myself because I see tremendous value in having a pocket size amplifier that puts out 75 watts. That's amazing to me.